Hello friends, let us look into an example of interpolation where we apply both Newton's forward interpolation formula as well as backward interpolation formula. So the example is the following table gives the values of tan x for x lying between 0 0.1 and 0 0.3. Find the value of tan 0.12 and tan 0.26. And here we are given with a set of values of x and tan x. Now x value is that tan x will be considered as our y value. So here we are asked with tan 0.12. So 0.12 you can see which is nearer to 0.1, that is beginning of the table, and we need to go for the forward interpolation formula. And the other value asked is tan 0.26, which is nearer to the last value of the table, and hence we need to go for the backward interpolation formula. So first we put the finite difference table. X values 0 0.1, 0 0.15, 0 0.2, 0.25 and 3. Corresponding values of tan x, that is y, we will note them in front of our x values. Now we'll go for finding the differences. Now since we are using both forward as well as backward interpolation formula, we need not go for two tables. The table we put will be same, only the denotions will be changed there. So just put the difference table. This value y1 minus y0, it is given here delta y0, or it is del y1. Now next one is y2 minus y1, this value 0.0516. Then it is y3 minus y2, we'll put it here 0.0526. Then we have y4 minus y3, that is 0.0540. Now we got the first differences. Next we'll go for the second differences, which are the differences of these first differences. So 0.0516 minus 0.0508, we have this value 0.0008. Then again next value 0.0526 minus 0.0516, it is 0.001, and again 0.054 minus 0.0526, we get 0.0014. Now these are the second differences. Now we go for the third differences. We'll take the differences of the second differences and write them as the third finite differences. So 0.001 minus 0.0008, we get 0.0002. Again next value 0.0014 minus 0.001. So here we have 0.0004. Now the last value, fourth difference, 0.0004 minus 0.0002. It is 0.0002. Now the difference table is over. Now the forward difference formula is used. For that we will take the first values in the table, these as the leading values, and when we use the backward interpolation formula, the last values in the table will be taken as the leading values. Now let us note them down. X0, first value of x, it is 0.1. Y0, first value of y, 0.1003. Then we have delta y0 0.0508, delta square y0 0.0008, delta cube y0, it is 0.0002, and delta raised to 4 y0, the last value, it is 0.0002 again. Now x we need. So x means it is the value at which we are finding the value of y, that is tan 0.12 we want. So we'll go for x as a 0.12. Now h we need. H is the difference between any two values of x. Take the difference between any of the two values of x, it is same, and it is 0.05. Now for forward interpolation formula, P is given by x minus x naught by h. X is 0.12, x naught is 0.1, then divided by 0.05. Substitute them, we get the value as 0.4. Now we apply Newton's forward interpolation formula. Now it is given by y is equal to y naught plus p into delta y naught plus p into p minus 1 divided by 2 factorial delta square y naught plus p into p minus 1 into p minus 2 divided by 3 factorial delta cube y naught. It continues until we have to look the last value of our table. It is delta raised to 4 y naught. So we'll continue this formula until we write that delta raised to 4 y naught. Now we'll substitute the known values here. Y naught, it is 0.1003, p it is 0.4, then delta y naught 0.0508, so on. Go on substituting all the values in the RHS of the equation. Then substituting all the values, simplify it, we get y as 0.1205. That implies tan of 0.12 is 0.1205. Now we'll go to the second one, that is we go for finding tan of 0.26. Here we note down these last values. Our xn becomes 0.3, yn becomes 0.3093, del yn will be 0.0540, del square yn will be 0.0014, del cube yn is 0.0004, and del raised to 4 yn it is 0.002, and the value of x we are going to take is here 0.26, which is nearer to the last value of the table. Hence we apply the backward interpolation formula, noting all these values. X value and h again remains the same, difference between any two values of x. Now p is different here. P is calculated by x minus xn by h. X is 0.3, last value in the table. Sorry, x is 0.26 for which we want tan value. Then here xn is 0.3 divided by h is 0.05. We get p as minus 0.8. Now write the Newton's backward interpolation formula. Y equal to yn plus p into del yn plus p into p plus 1 by 2 factorial del square yn plus so on. It continues until we write del raised to 4 yn, which is the last value in the table. Okay. Now here we have yn. In forward interpolation formula we have y naught. Note that difference. And here it is del yn, whereas in forward it is delta y naught. Again in this term, in forward we have p into p minus 1 divided by 2, whereas in backward we have p into p plus 1 divided by 2. Then here it is del square yn, in forward it is delta square y naught. So that those differences you need to note correctly and substitute the values in the correct formula here. Now after substituting, just simplify it, we get the value of y, that is tan 0.26 as 0.2660. That's how we will be applying here both forward as well as backward interpolation formula, putting only one difference table.